everybody, but I already know all of you. So welcome anyway to this presentation. I think that Emre has done a marvelous job putting together this document, and it gives us a very good foundation for thinking about what we should produce for other other learning strategies or learning frameworks that we are also going to try to address in the future. So this is for project-based learning, but we are also interested in IB schools. At the high school, their new systems transformation course. And then I think also data science would be another one that we should talk about as well. I think in each of these systems thinking, system dynamics is a very good approach to support the fundamentals of what they are trying to do. So Emre, please take it away.
Okay, thank you. And first of all, this will be a presentation of an example, not a proposal for a general use case, an example adapted for a very, very specific part of the department in Turkey's Ministry of Education. So you should keep this in mind. You have to always adapt the approach to the specific situation, especially for project-based learning, probably. So let me start my presentation and start reading my notes. So, and let me introduce myself. Emre Göktepe from Systems Thinking Association from Turkey. In this presentation, I'll try to describe how we are planning to embed systems thinking tools into Turkey's national project-based learning framework. And after that, draw some connections to IB systems transformation initiative. And so the Khwarizmi education model is Turkey's Ministry of National Education framework for project-based learning. It's currently running in over 2,200 schools with more than 9,000 teachers and 41,000 students. The framework structures student investigation through an 18-step scientific inquiry cycle from noticing a problem in their school or community all the way through to reporting and disseminating their solution. Our association has been developing a systems thinking implementation guide that maps system thinking tools directly onto the phases of that cycle. The name Al-Khwarizmi comes from a 9th century mathematician whose work gave us both the word algebra and the word algorithm. The name is a deliberate choice by the ministry. It signals a framework built on systematic, structured thinking. That framing aligns naturally with that system thinking offers. And this is the structure of the cycle. The 18 steps fall into 5 broad phases. System thinking tools are most relevant in the middle during investigation, root cause analysis, and solution design. That is where our implementation guide inserts the tools, not as an add-on, but as the analytical method in the inquiry cycle, already calls for at those stages. Those 2 slides are for introduction, but you're very familiar with these concepts. I'm skipping these. And here is the implementation guide slide. This guide currently includes 6 project examples spanning pre-K through high school. Each one is grounded on a school scenario: food waste in the cafeteria, unused land that could become a playground, school carbon footprint. Each project includes a Stella interface hosted on IC Exchange, so teachers and students can run the model interactively. So let me show. I will share all these slides, links in chat after the presentation. So this is the guide. It's a 74-page document, starting with introduction of general Khwarizmi education model, and what are those 18 steps, and how they align with each step, the relevant ones, how and in which purpose it aligns. And after that, the first chapter is introduction, because this will be used by the teachers, probably have not been any training on systems thinking, so this might be a good way to start some giving some information about very basic money in piggy bank, for example, stocks, flows, and behavior over time graphs. And after that, the first project example comes. This is about the kindergarten project. These project subjects, the questions are all from came from the department that is responsible for Khwarizmi's project in Ministry of Education. So they want these questions to be as examples, and then we worked on this. And as the steps orients, the first thing is noticing the problem, how this question come up. This is a very scenario, of course, how that might be done, and investigating and proving the problem. So we use behavior over time for this. And as this is a kindergarten level, we do not have units or any kind of written information here. Instead, from a wilted, unhealthy plant to a healthy plant, some images. We can put also some images here, but in this way, this was the time. So they know 1, 2, 3, 4 until 10, I think, for kindergarten level. It starts with, it always starts with a kind of behavior over time graph to create a way to prove that there is a problem. So this is the problem, and actually they are making some experiments for groups in the scenario, and after that they start conceptualizing the situation using stock flow diagrams. So this diagram all full of images, and this makes inflows are healthier. What are the things that makes a plant healthier, and what are the things that drains that health? And here are irrigation, sunlight, and good soil, and opposite of it, of course, decrease. And then as the as a summary of all the things they have done, these are the events that they observed before the project, and these are the examples or experiments they have done to select what to do, and these are the structures. This is the structure that creates this, and after that, using this visual aid, they propose some improvements, and actually this is the improvement of course. And the others are, how can we reduce food waste in school cafeteria? Can we transfer more schools' unused land into a playground? And the sixth one is what can we do to reduce our schools' carbon footprint? This is for, of course, high school level. It gradually increase the level, but the subsections are the same: noticing the problem, proving the problem, and this proof is again with behavior over time graphs, but a more sophisticated, a more complex one comparatively. So this is, of course, a much more complicated. That one, the first one was one stock, and we have three stocks here. And
Can you explain? Can you go and explain this a little bit?
okay, so this is the problem is carbon footprint of the school. So this is a stock, an imaginary stock, of course, school source carbon dioxide accumulated in atmosphere, and this accumulation is done by monthly emissions or everyday emissions, but here the unit is taken as monthly because their observations will be by month. So among the most affecting variables to these emissions are found to be number of vehicles used for commuting and school heating. So this is the initial stock flow diagram. So this is a stock, but no inflow or outflow. It will be designed this way because this will be the one that will be decreased in time. Currently, it's a standalone stock, but this is a flow school heating, and this heating is necessary because outdoor temperature is lower than the desired indoor temperature. So the heat inside the school or the temperature of the school, heat is always trying to escape or heat loss through heat loss outflow. So the heat goes down, and if heat goes down, the school temperature goes down, and with this low temperature, there's a disparity between desired temperature and school temperature, and required heat is given through some devices, and this creates a school heating inflow that makes the heat inside the school increase. Actually, this is a physics or chemistry, not this part, but this part is a chemistry lesson. So by this way, we keep the heat inside the school in control, but the cost is monthly carbon dioxide emissions. So these two creates most of the carbon dioxide accumulated in atmosphere by school. And let me this one. So this is the post intervention stock flow diagram. Let me increase a little bit. So this part is the same. The red ones are the interventions, and this part is also an complete intervention, because with this part, the monthly carbon dioxide emissions, this is only an inflow, and the school can only increase with this flow, or if it stops doing all the emissions, the accumulated account will be the same. But the school decided, or the students decided, actively decrease the carbon dioxide accumulated in atmosphere by school with increasing the amount of green area and number of trees. By this, they are taking atmosphere carbon dioxide. They are removing the carbon dioxide from the atmosphere. And these are the two interventions. And another one is car sharing. So when they decrease the number of vehicles used for commuting, they automatically decrease part of the emissions, monthly emissions. Two other interventions can be, one of them is insulation. So it will decrease the rate of heat loss, that might be a huge saving for school heating. And another one is to put a thermostat or create a new set for the thermostat for the desired temperature. So these all are before and after situations. It can be observed in behavior over time graphs, and this is the emissions and carbon dioxide removed from the. These are the two flows, the inflow and outflow of the carbon dioxide in atmosphere stock, and this is what happens to the stock. And it is important that the students to see that the slope is decreased. It is still the school still increases the carbon dioxide in atmosphere. So this is not a neutral thing, but if we compare it with before month 6, it is an improvement. Otherwise, that will be go this way. So this is an example about high school, and as a conclusion, we put.
Do you want to show them the model, the actual interface that you
Yes,
created?
here we have.
It's in Turkish, though.
Yes, but the same model, only in Turkish. But the difference is, of course, when you click this, it works. It has some. Not all of them are visible here, but it has the mechanism. It's a numeric model, and each of these are the interferences. The first one, second one, third one. This is car sharing until you do all of them and see the results of it, and in which case what you are doing here. And this is the model with other invisible parts. If interested, I can share the models file, STMX file. So this one, each, not for the one for the kindergarten, but the other four examples all have this kind of interfaces showing it's a workable, it is runnable interfaces. And for the conclusion, we put the department asked for it to have a kind of quick reference card on what to use, when to use, and tool usage. Check their own behavior over time graphs if it is correctly constructed or not. For the stock flow diagram, causal loop diagram, and some connection to the main guide. And of course, the AI use, because I very much used Cloud AI for creating this document, even translating it into English, I used it. And the last page of the presentation is this alignment page, the IB connection. The IB board approved the expansion of systems transformation course a couple of weeks ago. They will do a wider pilot in 2028 and global implementation in 2030. This is a possible alignment table for systems transformation course. The course can make use of the tools our guide provides. Stock flow diagrams, causal loop diagrams, behavior over time graphs, and the iceberg as a visual summary for project reports. One important difference, of course, the current IB systems transformation is positioned at diploma program level, ages 16 to 19. Our guide provides from 4 to 18, but that grade level progression and the teacher support materials built into each step may be directly relevant if IB plans extending systems transformation into PYP and MYP. So I think this is the end of my presentation, and let me share the.
Thank you.
Thank you very much,
You're
Emre.
welcome.
And he has put the document URL in the chat. So if you want to actually have access to the document, you want to save the chat. Do you have any questions about this? What I think that was really important is that he used the project-based learning format and then tried to show how the system's tools would apply within that framework. So teachers who are using the project-based learning format recognize the examples that he used in the document and the steps that is from their approach, and then showing how the behavior over time graphs and the stock flow diagrams. And toward the end, he didn't show you this time, especially in the high school one, he did causal loops to show some of the feedback loops. Also in the iceberg for under structure. I think that's really, really important to try to use as much of the language and structure of the learning frameworks that we are trying to infect with our tools as possible to make our potential audience as comfortable as possible looking at the tools that we have to try to help. So I think the document is a great starting place for us.
Yes.
And so I think that this is the beginning. We want to also talk about IB schools and then probably data science, because I think those are two other important approaches for learning that we can influence and assist. Manish?
Yeah, I had a couple of questions and comments. I really love the document, and I can see, teachers really being able to use this. Is this the example of the carbon footprint? Is this already been taken to school, or is this handbook for, it's what is proposed to be sent to teachers?
Well, it is not implemented in any school. They are all made up scenarios. But if it is being done, it will be done once, because there won't be another project, because each project should be different from the others. So, but the idea was from the department, so it's about, of course, sustainability, and but this might be adapted, not as a carbon footprint, or they might change the structure. Instead of heating, they can put another, or cooling, maybe they can reverse the process.
Yeah. So just I was kind of thinking as I was watching, if a student were to apply a reductionist approach to say carbon footprint caused primarily by heating and by transport. So what can we do in heating? We can become more efficient. What can we do in transport? We can do carpooling. Would that be okay, or would they miss something if they haven't used systems thinking approach and instead use a reductionist approach. Just let's break this down into its parts and solve each part.
Well, it is very easy to make something complex. You just put everything, and probably for the very short time, the only person understand it will be you. And after some time, even you do not understand what's been done there. So I think it is the purpose of systems thinking to do the reduction. But the thing is, what you are throwing away. So how you reduce is the critical point. So when if you see that the cars and the heating is 80, 85, 90% of your problem, then systems thinking is useful to show you the mechanism of it. But of course, before that, you have to do the work of selecting the real variables. That's a problem in itself, but it might be useful to have the behavior over time graphs beforehand. So after you make your assumptions and create your model and do your interferences and change the system, you can just check afterwards if that behavior over time graph changed. If not, you can always go back. This is a feedback, and you can always go back and change the structure. This is how I taught, and it is documented, and it is also documented that this is not true. So you again make another assumption and another reduction, actually, because if you really made the model as it is, then it will be, I'm afraid, too complex to work with or to even understand.
I would like to suggest that it's really important for the students to be part of the conversation of creating the model structure,
Yes.
the stock flow diagram. For them, maybe they can make the behavior over time graphs, or maybe they find those behavior over time graphs on the internet as a guide for what they are trying to use as a foundation of data for the model. But I don't think we want to just give students the stock flow diagram. I think
No.
we want to try to pull from conversation with the students what are the important pieces that are involved in the model, and maybe even as a class start to construct a stock flow diagram from that. You can say, well, here is another group who worked on this problem, and here is the model that they came up with. If you want students to actually play with a simulation that is all ready for them to use, you could do that. But I think it's important for them to help design a stock flow structure. Even if you can't put numbers in it and have a working model by the end of the conversation, you could then transfer over to, here's another group that worked on this, and this is a working model, so let's play with this and see what each of the interventions, how it impacts the CO2 level footprint for the school. But I wouldn't do the second thing without at least working with the first thing, because that's the beauty of having a two-dimensional shape of representation of the structure of the model that helps them realize that they don't have to do a mathematical equation. They have a very good representation with the stock and flow diagram to
In the
help
sense,
understand.
in the sense, I think the counterintuitive behavior is the most compelling, attractive thing about system thinking for me. So the playground and the carbon stories already carry a lot of counterintuitive behavior. So counterintuitive behavior sparks the
Yeah.
learning motivation.
Yeah.
Yeah.
So I'd love to spotlight the counterintuitive behavior as a title rather than hide it in the closing note. So I would recommend if it is too late, if it's not too late, putting the title, right in the chapter and the section title. Yeah, that is my idea.
Yeah. Thank you. I think that's really important because it is very stimulating
Yes,
from the modeling experience to
yes.
see that. Yes. Um, well, let's see what else. We talked a lot this morning in the first meeting because we had someone from IB school. So our conversation sort of shifted to how we would do this with the IB school. But one thing Emre said, because he's always coming up with these amazing documents, is that he
Yeah.
did use AI to help him design these documents at the beginning. And I think that's really important for us if we are going to try to do this for IB schools and for data science as well, that we can use AI to help us begin the document of aligning the requirements of the approach, of the learning approach or the instructional approach with some of the systems thinking tools. But I'm not sure that that particular conversation is going to be as useful in this meeting as it was in the first meeting because we had some IB people in the first meeting that we were really trying to interest in working with us on this next document. So, are there any other questions? Did all of you read the document? Have you actually been able to read the PBL project-based learning document to see how the examples were all set up in the steps and the different examples that he had in there?
I will
I
be
know.
after my grades are due in a few hours.
Oh, yeah, well, that's a different story, right? It's hard when you're still teaching full time to stay up with this. So, and Peter, you're still teaching now, or is your school year over?
Peter, you're muted.
Okay,
Okay,
before
it's
the
all right.
Peter ready, I want to I want to say something. The presentation gives me some imagination, and so because if I propose the system thinking education to the ed education of administration in South Korea, wow, there's good point. There's good starting point in there. So in that sense, I categorize three parts: why, what, and how. And I noticed across the sessions that you spend most of time on the what system thinking is and how to introduce it. But I think there is a very little time on why it is needed.
Yeah.
especially in the you proposed in the perspective of project learning, project-based learning, something like that. Okay, so what is the problem in the PBL in Harismi education? What is the problem? So that system thinking can solve that problem. That is why you need the system thinking, something like that. So
You are right, but
Mm.
that's why I have before starting the presentation, it should be adapted according to each specific situation.
Okay.
In our case, let me share. So this is the Harizmi Education Model Implementation Guide. This is the official document of the Ministry of National Education, Secondary School Administration, and here in this guide, and these are the ministers and other people.
Aha.
And here in this official document, we have this part.
You missed it. Go down. Yeah,
Yes.
I saw it. Down a
So
little bit.
this is
Oh, okay.
systems thinking in education,
Wow.
and systems thinking and system literacy skills. This sub
Wow. It's
section.
already there. Wow.
Yes.
Yeah.
And so
Ah.
we have this. They just we have already answered the why question, and this document is published last October, I think.
Last October. Okay.
Yeah. So
Oh.
uh,
Congratulations.
yes, and this is our first introduction as a Systems Thinking Association into an official document. So they knew who we are, and when we contact them, we are all welcomed. And we made some
Okay.
trainings and workshops and some more presentations. So after that, we asked if they would like to have a companion for their general implementation guide that instructs how system thinking tools can be used, because in their document they have the system thinking tools to be used, but the problem was they don't know how to do that. They have some information there, but it is not, of course, sufficient. It is a very small document. So this one is a companion of that document.
So
And
this is a very next step.
yes,
Yes.
next step. And the first step, the first step takes 10 years, probably maybe more, to create that main implementation guide, to make it. And after that, it takes a couple of months to create how that why part is being done implicitly, explicitly, working over by the teachers, by the academicians, any way we can do to infuse this notion, the systems thinking approach into the ministry's documents. And the first document, this was actually the second document. The first document is a 2024 curricula. The Turkish education system updated the curricula in 2024, and in that document, one of the documents, the common document, was mentioning systems thinking the first time in Turkish education history, in any curriculum. So the first mention was there, but there was no mention of the association or any reference to the tools. This is after 2 years, after 2 years, we have a guide that is mentioning the tools, but no specific instruction how to use that. And now we are planning with the department the guide. And so this is the history actually. It looks like one document, but it takes 15 years to create this one.
Yeah, that situation, that history is very similar to ours. Even in the official document of education of a ministry, there is a system thinking.
Yes. So
they don't
this is the
know
part
how
we can
to do it, and they don't know what is it. So, Emne, I need the official document mentioned the system thinking. I don't. It doesn't matter the language. So, please share that Turkey official document in Turkey language. It doesn't matter. Okay.
Let me share it. And
You're amazing. Oh, I thought this proposal is the first time to introduce a system thinking in your country.
yes, the first. So here is.
Okay. Yes. Yeah. Thank you very much.
So it's in the chat. So you may want to save it if you want to get.
This is the updated version of the common text. The first one is 2024, and the updated version. Not our part has any changed, but other parts of the document, the 2024 changed. But this 2025 is the currently used one. If you'd like, I can give.
The document hold the system thinking. It matters.
Yeah. Right.
Yes.
Right. That's it's really great to see what's happened in Turkey and also in South Korea. I feel like the United States is so behind on this, not having it, I don't think, in any state. National curriculum, there is no national curriculum. Each state, well, there are some generalities, but each state kind of makes its own more or less more specific details. But I don't know at this point if any state has included systems thinking.
Diana, you envy Turkey.
I do envy.
Well,
Yes.
actually, the accumulated or the work done in United States, it is many times more than any of the countries summed up to all together. So, but I think the problem is the focus of the effort. The focus was always teachers or schools. This is needed, of course, but after this, in our case, in Turkey, the way to change a curriculum standard goes through academia.
Yeah.
Because whenever they change something in curriculum, almost always, not almost always, they ask from the professors
of education. Yeah.
And so our focus was to show all these things that we are doing to the academia. And when they persuade that, when they are persuaded to that this is a good thing, and actually it is a good thing because with their point of view, this is new. They can make a research on it. They can they can make a difference with using this, because by definition it is not used. So when they start using this and get used to it, of course, whenever the Ministry of the Curriculum facility or department asks any idea, they in not maybe this year, but next year or next year, they mention about systems thinking. And after some mentions in 5 years, 10 years, ministry is interested in,
Starts paying attention. Yeah,
yes, but it is very slow, of course.
right.
You are working with government and everybody wants to put something in there.
Right.
Uh,
And that's something that we have not done. We have not focused on including professors of education in our particular efforts. And I think, see, that's one reason I think Turkey has been so successful is their particular approach has been very systemic. They really have looked at the whole
Right.
picture. If you want to change education, you got to go from the classroom to the training of teachers, all the way to the education professors who train the teachers for the next year's classroom. And they've done that. And I think it's been very effective. So anyway.
In that sense, this is my curious point. I think there is some tension between Harizmi education and system thinking, because the Harizmi is very, very symbolic as a systematic thinking, as a mathematicians, something like that. So the officials of education of ministry tend to think of system thinking as systematical thinking.
So you think that because the name in the document is based or patterned after a mathematician who lived many years ago, it sets a foundation for a more structured approach to learning, which then, of course, lends itself to system dynamics kind of approach. That's very possible.
Very possible, I think.
Yeah, very possible.
Okay.
So.
Let me see. Okay. Good.
Well, I don't have anything else to say, and I don't know if anyone else has anything else they would like to say. We could finish this meeting early if no one else would, has anything else, but we appreciate that you have come, and we hope to do some more in the future. Probably our next meeting will be in August, not in July, but in August when we talk about our goals. It's really the meeting sort of associated with the International System Dynamics Conference, our pre-college meeting. And we do that once a year, and we talk about the goals we have for the coming year. So we hope that we will see you. It will be the 4th week in August at this time. And so then we have not planned the fall webinars and meetings yet, but we hope that you will come back and that we will see you in a few months.
Yeah, thank you as always.
Okay.
Yeah.
So for some of you, we'll see you next week because
Okay.
you are on our regular weekly meetings, but for others, it will be a few months. So have a good summer, and
Bye.
we will see you later. Thank you for coming.
Thank
Bye.
you.
Bye,
Bye.
Manish.
Bye, Manish.
Bye, Manish.
Thank you.
Okay, bye.